Hi everyone. Welcome back to Dave's Math Channel. I'm your host David Tear, and this is my second video on a new series called Math and Science. Today I'm going to talk about population growth. And this is going to be a pretty qualitative lesson. I'm not going to, give you guys a lot of math formulas because the formulas are pretty complicated in this case, and they're kind of hard to derive too. But I want to give you guys at least a good qualitative idea about what's going on with population growth. So on this slide, you'll notice there's a little graph. I'll get to this one later, but this is kind of a recent graph of world population projections going up to, I guess the late 21st century. And population growth, world population growth isn't anywhere nearly as big a problem right now as people used to think it was like 50 years ago. I remember when I was a kid, everybody was really alarmed about world population growth because the world population was growing much, much faster than it is today. And, people were predicting there were going to be a lot of big disasters. But the good news is it seems like we seem to have world population growth under control, at least for now. I'll get to this later. But um, I just want to talk about world population at first. So, this graph actually, it's really hard to read this graph, but this graph shows you the world population over the last 12,000 years. And it just skyrocketed very, very fast. I'd say in the last 200 years or so. I mean, most of world history, the world population was very, very small. 12,000 years ago, I think it was only maybe something like 100 million, or probably even less than that, maybe 50 million, 100 million. I used to hear it was around 100 million around the beginning, the dawn of civilization, and I think it was around maybe 250 million around the time of Jesus. And I think it didn't get up to a billion until the Industrial Revolution, which was only about 200 years ago. And then I got to like 2 billion. It didn't even get to 2 billion until around 1930. That's what the world population was when my dad was born. My dad was born in 1930, and he was even taught in school that the world population was 2 billion. Because that's about what it was at that time. Now it's over 8 billion. In 2022, the world population got up to 8 billion, and it was growing very, very fast. If you want to talk about growth rate, the growth rate of the world population actually peaked in 1962. It was like 2.1% per year. And that's exponential growth. It's actually throughout most of world history, it's grown even faster than exponentially because, early on it wasn't growing as fast. Not only, it was a very small, but it wasn't growing very fast either. It only started growing really fast in modern times due to all the modern technology we have. There are a lot of reasons for it. I don't want to go into those in too much detail right now, but anyway, and then to have a little more recent graphs of world population and see that it's not as big a problem as it looked like from the first graph. This shows a little bit more of world, more recent history. I think this graph starts out around 200 years ago, maybe 300 years, around 1700, and you can see it was growing very fast from 1700 to about maybe 1950, 1960. And then there's kind of an inflection point. I don't know what year this is, but you see the point where the slope kind of stops increasing and starts decreasing. It looks kind of linear for a while. I'm not sure. I can't really read this graph, but I think this is probably maybe around 2000. I don't know when it reached this inflection point, but now the world population growth rate is actually slowing down. And it's been slowing down for a while. And that's good news, like I said. Um, this is the graph I showed on the first slide. This is just projections up to 2100, I guess. Here's where it is now. Where it's the dotted part of this graph is the projection, and right now we're in 2024. So right now we're about 8 billion. I guess this is 2022. But yeah, so it's gonna go a little, it's projected to go around 10 billion and then basically stop and maybe even start decreasing a little bit. And it probably should decrease because I don't think we need 10 billion people on this planet. We've got enough problem with the 8 billion we have already. So anyway, but I mean, I want to get more to basics about population growth right now. So now I've just been talking about the world population growth. Let's make this discussion a little more abstract. So here's two different models of population growth. The model on the left is what's known as exponential growth. This is growth that gets very, very fast, very, very quickly. And this is where you have kind of unlimited resources. And I guess the reason why the world population has been growing exponentially for so long is because we managed to, create enough resources for the world population to grow as fast as it did. I mean, it's no coincidence that the world population started growing really fast right after the Industrial Revolution. Because think about what happened with the Industrial Revolution, right? We were able to, we had our first machines, we were able to produce more goods, we were able to grow more food, we were able to provide more resources for everybody. So naturally, the bigger your supply, the less inhibited the population is to stop growing. But that's exponential growth. That's kind of unlimited growth. And that can never be sustained. It doesn't matter how many resources you have. Eventually, exponential growth, actually, after a very, very small amount of time. I've done calculations like this. I mean, if the world population had continued to grow exponentially at the rate it was growing in 1960, then I've seen predictions. Like, people were worried about this back in the 70s. People were saying if the world population keeps growing the way it is, by 2600, there'll be like one person per square foot on Earth, and by like 3700, humanity's gonna, have the same mass as the whole Earth. I mean, things like that were true. And if he kept extrapolating, at some point, humanity would fill up the observable universe, or would be, growing at a rate where it would make a sphere that's expanding at the speed of light. And it doesn't even take that long with exponential growth for that to happen. But obviously, that doesn't happen because exponential growth cannot be sustained. I've done similar calculations involving bacteria cultures. I remember doing a exponential growth calculation involving a bacteria culture that was doubling every 20 minutes. It started with 100,000 bacteria, and then after 100 hours, it would take over the whole world. Obviously, that doesn't happen because there's no bacteria culture that can sustain that many bacteria. So don't get too alarmed about exponential growth. It can't be sustained. And this model on the right is a much more realistic model. This is what's known as logistic growth. And you can see it has kind of the same shape as the world population is right now. What's happening here is that the world has a limited carrying capacity. We can only support so many people on this planet. We can only grow so much food. We only have enough supplies for a limited population. So it's no surprise, as we're approaching the limits of what we can sustain on this planet, our population has to slow down. And it's a good thing it is. And this is a much more realistic model, not just for humanity, but I mean, here's just a picture of exponential growth. I don't even know why I included this here, but this is basically what exponential growth is. It just, I think in this picture it's doubling every generation. So that's really all exponential growth is. It's where it multiplies by a constant factor after a fixed amount of time. And the guy, yeah, I guess I have to back up and talk about exponential or Malthusian population growth. The guy who came, it was named, so Malthusian population growth is just another name for exponential population growth. And it got its name from this sociologist from the 18th century, Thomas Malthus. He was kind of an alarmist. He was warning people back in the 18th century. He said, the world population is growing exponentially, but our food production is only growing linearly. So at some point, people are going to start starving. And obviously that didn't happen. What ended up happening, it could have slowed down because we were approaching our limit, but it didn't do that. What happened was we had the Green Revolution. We had the Industrial Revolution, then we had the Green Revolution. So our food growth capacity did end up growing exponentially, and so it didn't slow down our population growth. So Malthus was wrong. Um, but yeah, this is logistic growth. I already talked about that. and it has a limited carrying capacity. And it doesn't just apply to people; it applies to animal species too. As a matter of fact, I think I should mention one more thing. Charles Darwin was very heavily influenced by Thomas Malthus. That's where he that his Malthus's ideas about limited population growth and competition. That's kind of what led Darwin to come up with this theory of evolution by natural selection and survival of the fittest. So, and it does work in the animal kingdom, and it works for on the left. You have bacteria. I was talking about bacteria culture a few minutes ago. If you have a bacteria culture, it has a limited feeding capacity, so the bacteria grow until they can't grow anymore. And the same with other species. This is seen all throughout the animal kingdom. And I think things get a little more interesting when you have competing species, because then populations, I mean, here you have two different species of animals. I guess the red animals are the predators. I forget which is which. Yeah, I think the red ones are the predators, the blue ones are no, it's the other way around. The blue ones are the predators, the red ones are the prey. So there's three kind of things that could happen. Either you get so many um, uh, either the predators die out and then the prey can reach its carrying capacity, or yeah, I guess this is the case. Actually, the predators I think are the red ones. So either they eat all the prey goes extinct, and then the predators. Well, actually, the predators will die if that happens. I don't know what they're showing here, but the basically I mean the most interesting one in this case is the one on the right, I think, because if you can have a point where you reach equilibrium between predator and prey. It's kind of well, they oscillate around a kind of what do you call it, I forget the name, equilibrium. Yeah. So that's what happens when you have competing species. And anyway, I guess that's all I have to say for today. So anyway, thank you for watching. Long live math, and I'll see you guys next time.